So let's have a look at these here, guys. So for question number 1, okay, we're looking for how many moles of ammonium bromide there are in 200 grams. All right, so the first thing we got to do, okay, is figure out the molar mass of the stuff we're dealing with. Okay, we've got NH4Br, and you were lucky because I didn't make it the name I gave you the formula. Okay, so how many nitrogen here? 1. All right, so we got 14.01. Okay, how many hydrogen? 4. So that'll be 4.04 because each hydrogen's 1.01. Okay, and how many bromine? 1. All right, plus 79.90. Okay, so we got to calculate what that is. Okay, so we got 14.01 plus 4.04, okay, plus 79.9. All right, so we're looking at 97.95 grams per mole. Okay, and they told us the mass was 200 grams. So there's our first mark. Now, if I want to calculate the number of moles, I don't really have to do any manipulating because the formula is already set up to calculate number of moles. All I have to do is plug in my numbers. All right, so big M they told us was 200 grams. Okay, we calculated the molar mass, 97.95 grams per mole. Okay, so you can give them a mark if they've got something that looks like that. And then we just have to do the math. 200 divided by our molar mass gives us 2.04. What? Moles. Like, what's close? Oh, they rounded off? Okay, always take it to 2 decimal places. Okay, 2.04 moles. If they have 2, we'll accept it today. Okay, they must have the units, though. If it doesn't have units, it's not right. No, then the units are wrong. Okay? Then they are very, very lucky. Yeah, you still give them, I mean, they put the numbers in the right place, so. All right, any other questions on that one? Hey. For number 2, I've got 12 moles of iron 3 bromide. What is its mass? All right, so the question gave us N, 12 moles. Okay, they told us the material. Okay, iron 3 bromide. All right, so we're going to have 55.85, and there's only one of those. Okay, plus 79.9 times 3. All right, so we're looking at 295.55. And that's grams per mole. Okay, so if they've got those, that's their givens. Give them a mark. Okay, so now I want to find the mass. N equals little m over big M. I need little m by itself, so what do I do with big M? Multiply both sides by it, right? Okay, give them a mark if they got that. Okay, then they'll get a mark for plugging in the numbers correctly. So that'll be 295.55 multiplied by our 12 moles. All right, gives us 3,546.6 grams. Okay, so a mark for the numbers, okay, and a mark here for the answer. Again, it must include units. If they rounded to 3,547, I'll let that go today. Okay, but in the future we want 2 decimal places. All right. Questions on that one? And? So you didn't show the manipulation? Show the manipulation from now on. I'll let you have it, but okay, you got to show the manipulation. If I'm going to give you marks for steps, the steps have to be there. Okay? Right? I mean, in the end, if you got the question all right on a test, all you would write, if all you wrote was the correct answer, I would still have to give you full marks, because you're either a brilliant guesser and deserve full marks for that, okay, or you showed all the work and got the right answer. But here's the thing. If all you show is the answer and you punch one number wrong on your calculator, now what do you get? 0. Okay? When you probably knew how to do the whole thing. Okay? That's the importance of showing your work. All right. Last one. What's the mass of 1.5 times 10 to the 25 molecules of lithium sulfide? All right, so they gave us the number of molecules. Okay, so that's 1.5 times 10 to the 25, and they told us the material we were dealing with, lithium sulfide. That stuff. Okay, importance of swapping and dropping. So we got 6.94 times 2, okay, plus our sulfur, 32.07. Okay, so 45.95 is our molar mass. Okay, so there's their Givens mark. What can I find if I know the number of molecules? I can find N using whose number? Avogadro's number, right. Okay, so N is going to equal the number I have, 1.5 times 10 to the 25, divided by Avogadro's number, which is 6.02 times 10 to the 23. All right, so we're looking at 24.92 moles. Okay, they can have a mark for that step. Now that I have N and I have big M, what can I find? I can find little m. All right, so N equals little m over big M. Okay, and I have to manipulate that by multiplying both sides by big M. Actually, this is going to be out of 5 marks, not out of 4. Okay, give them a mark for the manipulation. Then they're going to plug in their numbers, so little m is going to equal 24.92 multiplied by 45.95, our molar mass. Give them a mark for that. Okay, gives us 1,144.93 grams. Okay, so that one's out of 5. Questions on the third one? All right, so the whole thing was 7 and 5 more is 12. Okay, give them a mark out of 12. Okay, write it at the top, please. Let them see it. Then hand them into the box. Back to your desk. We're going to talk about your toxin project before we move on to more mole stuff. Okay, let's have a look at number 1 here. Okay, so for number 1, okay, we're told that we have 65 grams. Obviously, question number 1 is an example of the easiest kind. We're only looking for the number of moles. Okay, we're told the mass, we're told the material. Okay, so we write down our givens here. We've got a mass of 65 grams. We have a molar mass of 18.02 grams per mole, calculated by taking 2 hydrogens, okay, here, and adding it to 1 oxygen there. Okay, then we just plug in the numbers. We don't actually have to manipulate the equation because it's already set up. So mass over molar mass, and we get that this is 3.61 moles. Taylor, question? Yes. All right, everybody good with that one? Yeah, how many people have done number 2? All right, let's look at number 2 then. Okay, so for number 2, we're asked, what's the mass of 8 moles of magnesium chloride? Okay, again, ionic compound that has to be what? Swapped and dropped. And if you forget that, you're going to have a lot of trouble getting it right after that. Okay, so we're told that there's 8 moles. Okay, we have to calculate the molar mass. So we've got 1 magnesium and 2 chlorines because magnesium chloride is MgCl2. Okay, that gives us a molar mass of 95.21 grams per mole. Okay, then we calculate mass. We have to manipulate the mole equation by multiplying both sides by m. Okay, so it comes over here. Then we multiply 95.21 by 8 moles, and we get a mass of 761.68 moles, or sorry, grams. All right, and people have done number 3. All right, let's go over that one too. All right, so how many molecules of sodium iodide are there in 200 grams? Okay, so again, we're told it's sodium iodide. That's an easy one. If you forgot to swap and drop, you would still get this one right because they're 1-to-1. All right, so we got our 22.99 for sodium, our 126.9 for iodine, which gives us a total molar mass of 149.89 grams per mole. Okay, our mass given to us in the question was 200 grams. So if we want to calculate number of molecules, we need Avogadro's number and the number of moles. So first thing we can calculate is the number of moles, and is already the mole equation is already set up for that. Right? So 200 grams over our molar mass tells us we've got 1.33 moles. Okay, then to calculate the number of molecules, we take Avogadro's number, which is the number of molecules in 1 mole, okay, multiply it by the number of moles, okay, so that's what we did right there, and then we get 8.01 times 10 to the 23 molecules of sodium iodide. All right? Everybody with me there? Okay. Finish up those mole equation worksheets, please. Okay, if you have questions on those, please ask. Okay, did yesterday, guys, did we talk about question number 6 at all? Yeah. We did? Okay, good. All right. Okay, guys, one other thing here. Yesterday, when I gave out your unit exam review package, I told you I didn't have much in the way of stuff on the key for that. I had a little bit of time yesterday, and I put a little bit more stuff, and by a little bit I mean like most of the key is now actually done. So when you are looking over that review package I gave you yesterday, if you want to see the key now, the key has a lot more stuff on it than it did before. Okay, I put the correct answers essentially in green. Now, for some questions I don't have anything there because it's more you're looking stuff up out of your notes and synthesizing it yourself. Okay, but for things like the naming, all right, I've put them in there with the correct formulas. Okay, the proper reactions are in there in my chicken scratch. Okay, the correct answers for the mole equation stuff is in there. Okay, and then for the multiple choice stuff, I also have the multiple choice answers highlighted in green. Okay, so I would say do them all and then go back and check which ones you get right or wrong. The only thing I don't have, guys, I have some of the written response, just the balancing. That was all I got time to do. Okay, so the rest of the stuff, you can practice them, but I don't have the answers for them. Okay, just didn't get time to do it. So most of it is there now. Okay, let's have a quick look at number 6 here, guys. What number 6 is really asking is, do you know the difference between an atom and a molecule? In a complex way, that's what it's asking. Okay, so there's a couple of ways for me to figure out how many oxygen atoms there are in 64 grams of oxygen gas. The issue here is that oxygen gas is actually a molecule made up of 2 atoms. So there's 2 ways to go about this. All right, I would say if I'm looking for how many atoms there are, I should use the molar mass of an oxygen atom, not an oxygen molecule. Okay, if I use the molar mass of an oxygen molecule, I'm using 32 grams, which means I'm going to find, when I use Avogadro's number and the number of moles, I'm going to find the number of molecules. But the number of atoms is actually twice that number. because the atom is made up of two molecules. So here's the two ways you can do this. Okay, I would say find out first the number of moles by taking the mass, which is 64 grams, and dividing it by the molar mass of oxygen atoms, 16. Okay, does everyone follow me here? Follow what I'm doing? Okay, if I do that, I'm going to get, okay, that this is 4 moles, right? All right, now when I take my 4 moles, okay, and I multiply it by Avogadro's number, okay, what do I get there? Okay, so I'm going to get 1.204 times 10 to the 24, right? Okay, that's the answer I have on the key, right? Yes? Is it? Someone quickly check. Whoops. Sorry, thinking ahead to the other method here. Okay, 4 times 6.02. Okay, sorry. So I get 2.4. Sorry, that's my bad. Okay, so I get 2.04, actually 2.05, because that was an 8 after it, okay, times 10 to the 24 atoms of oxygen. Now, the way most people do this is they say N is going to be 64 grams, the mass, and then they divide that by the molar mass of oxygen molecules. Okay, you guys with me here? I'm now dividing by a number that's twice as large. So I'm going to get a number that's half as large, right? If you divide by a number that's twice as large, you get a number that's half as large. All right? So what I get instead of 4 moles is now 2 moles. Right? When I multiply this by 6.02, okay, I get the number I had before, which is 1.204, okay, times 10 to the 24, which is half of that number, agreed? Because this is the number of oxygen molecules. The question wants the number of oxygen atoms. So if I multiply this number by 2, because that's how many oxygen atoms there are, I get this number, which is the correct number. Okay? So all that question is really asking is, do you understand that oxygen comes as a molecule made of 2 atoms? Okay. Yes, it would. Yeah, if it was any of the molecular elements, that's the way it would work. Okay, so it'd be best to probably just go with their elemental molar mass. That's the one that's on the periodic table, rather than multiplying it by however many are in there. Okay. Now, that depends. If they asked how many sulfur molecules are there, then you would use S8. You'd multiply by 8. But in this case, it asked for atoms, so you use the mass of the atoms. Okay. All right, any other ones giving us trouble? Don't be afraid to ask, guys. For number 7? Actually, number 7 requires no calculations. No. Okay? Which contains more atoms? A mole of iron or a mole of oxygen gas? Well, if I have a mole of oxygen gas, remember that oxygen gas is going to have 2 atoms in it, where iron doesn't come as a pair. Right? So a mole of oxygen gas has twice as many atoms as a mole of iron does, because oxygen is a molecule. This is not. Yeah? Follow me there? So that requires no calculation. Again, it's just asking, do you know the difference between a molecule and an atom? Okay? Tricky way of doing it, but that's what it's asking.